So Knewton Section 2.4 is finite and infinite geometric series. So when we looked at arithmetic series, recall that we didn't talk about infinite arithmetic series because they never are going to add up to something in particular because the terms just keep going either larger and larger or smaller and smaller. So with geometric series, though, we have two types, finite and infinite. So the three things we're going to do is find the sum of a finite geometric series, decide whether the sum of an infinite series is defined, and then if it is defined, to find its sum. Okay, so the sum of the first n terms of a geometric series is a formula, and we can actually, if we think about it, we can figure out how they came up with this formula. But this is the formula that we get, where here is a sub 1, the first term. Then we have 1 minus the r to the power of n over 1 minus r. So you can see that because we're dividing by 1 minus r, it's important that r not be equal to 1. And if it was, then you wouldn't have a geometric sequence anyway, because it would just be the same number because you're multiplying by 1, and so that's not going to be geometric. So let's see how we use this formula. The n, it's the sum of the first n terms. So in this question, it's the first 11 terms. So n equals 11. Then we can see our first term is 2. And then our r is 6 over 2, which is the same as 18 over 6 or 54 over 18. So we can see in each case it's 3. So we have r is 3. So we're going to find S sub 11, and I want you to label everything you do for me. So S sub 11 is called the 11th partial sum. It means add up the first 11 terms. Then we put the a sub 1, that's 2. Then 1 minus, r is 3. And that's going to be to the power of 11 because that's the same n as we see as the subscript on the s, over 1 minus the r, which is 3. So we do this calculation. If we do 1 minus 3 to the 11th, I get negative 177, 146. Over 1 minus 3 is negative 2. So you see you have 2 over negative 2. So that's going to cancel to a negative 1, which is going to make the sign opposite. And we get 177, 146. I think that was a lot faster than adding up 2 plus 6 plus 18 plus 54, and then finding the next 7 terms and adding them all up. Okay, so let's look at one that's given to us in a little trickier form where we see that it says find the sum from k equals 1 to k equals 6 of 4 times negative 3 to the k. Now you may be able to just pick out all the things you need by looking at this, but I'm going to look at what the first few terms actually look like, so I can get an idea of how does this sequence that the sum is made from work. So I'm going to get negative 12 for the first term. Then I'm going to have negative 3 squared, so I'm going to get positive 36. Then I'm going to get 4 times negative 3 cubed. So that looks like negative 108. So it looks like our r is negative 3. So you can kind of see it here that it's what's to the power. But the thing that might have fooled you is what is the first term, because here is the first term when k is 1. So it's helpful sometimes to explicitly write out a few of the terms so you can see what's going on. Okay, so we want S sub 6 because we're adding up the first 6. Number 1, 2, 3, 4, 5, and 6. So we have our first term, negative 12. Then we have 1 minus. Then the r is negative 3. And it's going to be to the power of 6. Over 1 minus r is negative 3. Okay, so if I do negative 3 to the 6th, I get 729, and it's a positive number, so it's 1 minus 729. So this is going to be negative 12 times negative 728 over 1 minus a negative 3 is 4. So I'm getting 2,184. And then this sheet I'm using is a worksheet that's available in the Canvas files. And if you look down, you will see, if you scroll down to the last page, oh, there's the answer. So we got the first one right too. So these worksheets might be really helpful for you to work on the concept before you actually go and try to work on your Newton homework. Okay, so find the sum of the geometric sequence given. Well, now they're not telling us the r. We have to figure it out. What do you multiply 5 by to get negative 1? So it looks like the common ratio is negative 1/5. So that's our r. And then we just have to count up the number of terms. 1, 2, 3, 4, 5. So we know our n is 5. And then we can see our first term here is also 5. So we're going to say S sub 5 equals the first term, 5. And then 1 minus negative 1/5 to the power of 5 over 1 minus negative 1/5. So if you're not comfortable with fractions, I would really recommend that you get the Casio calculator that I suggested in the syllabus. And it is really awesome for working with fractions. My expensive calculator is actually really bad at doing fractions, but those $11 calculators are awesome at doing fractions. Okay, so I'm going to do a little simplifying here. So I'm going to show you what I'm doing, and you don't have to do this step, but you might want to think about doing something like this. So I'm going to have 5 times 1 minus, and then it's a negative number when I do negative 1/5 to the 5th. So it's going to be plus 1 over 5 to the 5th power over 1 plus 1/5. Okay, then I'm going to distribute this 5, because that's going to simplify the numerator a little bit and make it 5 plus 1 over 5 to the 4th, because this 5 I'm multiplying by will cancel one of the 5's in the denominator. And then I see I have fractions in the top and fractions in the bottom. So I'm actually going to multiply the top and the bottom by the biggest denominator I see. And let's see why I would do that, because now I'm going to distribute, and I'm going to get 5 to the power of 5 plus 1 over 5 to the power of 4 plus 5 to the power of 3 when I distribute in the denominator. So you don't have to do it this way. You're free to find a tiny fraction there and add the numerator and multiply by the 5 and then divide by the 6/5. But to me, this way looked easier because I don't have a cheap calculator available. I only have my expensive one that doesn't do fractions well. So I'm getting for my numerator, 5 to the 5th is 3125 plus 1. So 3126. And then when I calculate my denominator, I get 750. Well, that's an even number over an even number, so that's going to reduce. So I can definitely divide the numerator by 2 and get 1563, and divide the denominator by 2, get 375. And then you can tell if a big number divides by 3 by adding up all the digits. 1 and 5 is 6, and 6 is 12, and 3 is 15. Add those together and you get 6. So the numerator divides by 3, and the denominator divides by 3. So I'm going to get 521 over 125. But now I'm pretty sure I'm stuck, that I'm not going to be able to do any more simplifying. So this is going to be my final answer to the sum of these 5 terms. And because you're given a fraction in the problem, you need to give fractions in the answer. You could use decimals meanwhile if they're exact, but you should never say that 1/3 equals 0.3 or 0.33 because it doesn't equal that. It's only approximately that. Okay, so I got 521 over 125. So I'm going to come down here and see how I did. Yay! Got it right. Okay, so let's look at the infinite geometric series. And an infinite geometric series only has a sum if the absolute value of r is strictly less than 1. So another way to write this same inequality is r has to be between -1 and 1. It can't be -1, that won't work, and it can't be 1, that won't work. And if you think about it, if r was bigger than 1, say 4, you're multiplying numbers by 4 and multiplying by 4, and they're just getting bigger and bigger and bigger, so there's no possible way that an infinite number of them added together would ever add up to something that we could find. So notice how you're going to tell it's an infinite series. It's going to have an infinity at the top of the summation symbol. So let's see what this looks like. If I do 1/3 to the 1 plus 1, that's going to be my first term. And then k is 2. And then k is 3. So if we look at the first few terms, we see we get 1/9 plus 1/27 plus 1 over 81, and so on. So you can see that your r is going to be 1/3. The thing that wasn't easy to see with the summation notation is that your a sub 1 is 1/9. So that's why I find it helpful to write out a few terms and see what they're doing and what they look like. So the r is equal to 1/3. So because r is between -1 and 1, the infinite series is defined. And that's all we're being asked here. Okay, now the next one, this doesn't look very geometric, does it? If I do 10 over 6 and then 14 over 10, those aren't even the same ratio. So this is not geometric. In fact, hopefully you're recognizing it as arithmetic. And so the infinite series is not defined. So you have to be geometric with r between -1 and 1. Okay, and then this next one, it looks like we're multiplying by something negative. Let's see if I have 0.7 over 7, and I have 0.07 over negative 0.7, it looks like we're getting that R is negative 1/10. So when R is negative, it makes the signs alternate. And then we're getting 1 decimal point smaller and smaller and smaller with each term. So because R is between -1 and 1, the infinite series is defined. And I know Newton doesn't make you write out all this, but I always will, so you may as well get in the habit of it. And when you're doing your homework, use good math practice. Okay, so let's look at these next couple problems and see if we have an R. So I have -1 over 3, 1/3 over -1. Yeah, it looks like R, these are all equal. So I have R equals -1/3. And then we have a formula that says the sum of the infinite series is A1 over 1 minus R, as long as the R is between -1 and 1. So we say it's defined because -1 is less than R is less than 1 when we have -1/3. So we have the first term, which is 3, over 1 minus -1/3. So 1 minus -1/3 is going to be 1 plus 1/3, or 4/3. So we have 3 over 4/3, which is the same thing as multiplying by 3/4, multiplied by the reciprocal, and you get 9/4. So when I first learned about this, I went, whoa, seriously? You can add up an infinite number of numbers and get a result. That's amazing. Okay, so this next one, let's see, if we were looking for R, we'd say, oh, this already broke, so it's not geometric. So the sum is not defined. If it was the first 5 or 6 or 10 or any number, it would be defined. We could find it. But the infinite series is not defined. Okay, then let's look at this next one. And again, I'm going to look at what the first few terms look like. So I'll have 5 times 1/4 to the 1, plus 5 times 1/4 to the 2, plus 5 times 1/4 to the 3, and so on. So I can see that my first term is 5/4, and then I'm multiplying 5/4 by 1/4. Then I'm multiplying 5/4 by 1/4 by 1/4. Sorry, 5/4, yeah, times 1/4, and then times 1/4 squared. So from this, we can see that the R is 1/4, and you could see that here, but the K, it's not K minus 1, and if you remember, our formula is A sub n equals A sub 1 R to the n minus 1. So because this is not K minus 1, that's why the first term is a little tricky. And I just write it out so I can see that A1 is 5/4. So then S, we need to say because 1/4 is between -1 and 1, the sum is defined. And we get A1 of 5/4 over 1 minus 1/4. So that's 5/4 over 3/4. Dividing by 3/4 is the same thing as multiplying by 4/3, and we get a result of 5/3. So the answers are all down here, so you can check and make sure. And that's section Knewton Section 2.4.